Before we get started, what is the value of using application insights with Power Platform applications? Power Platform Telemetry gives the ability for organizations to monitor their application, how it's performing, and how it's being used. Organizations can use telemetry to build dashboards and alerts to proactively monitor applications to identify performance issues, failures, and analyze user journeys. It can also be used in a reactive nature to troubleshoot reported issues. This ultimately helps in improving the application's stability, governance, performance, and end-user experiences. In today's agenda, we will start with an overview of application insights and the capabilities available. We will also look into the Power Platform native integration, specifically the Dataverse telemetry. We'll then look at a quick guide on getting started, followed by a closer look at App Insights logs, which is where the telemetry will be hosted, and then spend some time looking at how to query it. We'll then move on to the App Insights capabilities, covering performance, dashboards, alerts, and transaction investigation, and then Amira will take over and give an overview of model-driven apps, Power Pages, and Canvas app integration with App Insights. Let's start with a quick overview of Application Insights and the native Power Platform integration. Application Insights is part of Azure Monitor. Each Dataverse environment will require its own Application Insights resource and should be kept separate from other applications using App Insights. We will focus on some of the key areas of App Insights, such as logs, where the telemetry is stored in standard App Insights schema tables, queries, how you can interrogate and join tables using Custo, performance, what does the out-of-the-box performance analysis give you and how do you use it, alerts, how you inform your support teams of specific failures or thresholds that have been exceeded, user flow, how users are navigating the application. Usage and costing is important. The telemetry stored in logs is chargeable, and as such, cost estimates should be considered along with retention policies. Continuous integration, how telemetry data can be exported and further used in other services such as Power BI. Dashboards, the creation of specific dashboards to monitor key business scenarios. Exceptions, shows any failures with the ability to drill down and review the end-to-end transaction. And DevOps. If you're using DevOps for features and story management, you can create DevOps tasks right from App Insights. So if something requires further analysis, you can create the item and give context right from within App Insights. Power Platform integration overview. The out-of-the-box native application insights integration with Dataverse populates standard application insight tables and columns. In the table on the left, you can see where certain types of Dataverse telemetry will be written to. To date, page views, outbound network calls, incoming API calls, plugin executions, SDK executions, and exceptions are all part of the native Dataverse telemetry integration. On the right-hand side screenshot, you will see that there's a log area within the application insights showing the tables where you would typically go to create queries. Getting started and quick setup. Linking a Dataverse environment to an application insights environment. Prerequisites. You will require an Azure subscription and an App Insights environment, and need the contributor, writer, or admin rights within the App Insights environment. Within the Dataverse environment, you will require the system admin role. Once the Application Insights environment has been created, navigate to the Power Platform Admin Center. Within the Data Export area, create a new Data Export profile. Select the Azure subscription, the Azure Resource Group, and finally, the Application Insights environment. Once created, data will start exporting and populating within the Application Insights logs within 24 hours. Usually, it's much faster than this. To stop the export, you can simply delete the data export profile. To validate that telemetry is syncing to Application Insights, navigate to the logs area within Application Insights. Pick a table that will be populated from the Application Insights telemetry, such as dependencies, and just run a quick query. You should see some results returned, and then you can expand the node to see the full set of columns populated. Let's take a look at logs and queries in Application Insights. Model-driven app telemetry currently logs page loads and UCI outbound requests. Every time a user loads a page in a model-driven app, the data is exported to the page views log table. This only includes clean loads, where the accuracy can be measured. Currently, form, quick create form, dashboards, entity lists, and app loads are supported. Save form and command button actions are currently not available. UCI requests are exported to the dependency log table and track outgoing page requests, whether to Dataverse or other services. Dataverse telemetry. The telemetry export for Dataverse currently provides performance data related to the Dataverse API incoming calls, Dataverse plugin execution calls, and Dataverse SDK calls. It also provides data for failures in plugin and Dataverse SDK operations. Incoming API calls. These are any calls made to the Dataverse API, whether from within a model-driven app or custom clients. These are found in the requests logs table. Typically, usage would be evaluating the number of calls by user, analyzing the performance of a critical API, and how this may change over time with releases, and reviewing end-to-end transaction by linking the API incoming call to the telemetry and other log tables. The Dataverse plugin execution logs. This will export to the dependency table where the type equals plugin. This would log useful information so that you can analyze the performance of a plugin, such as the execution time, the depth, and the number of executions, and then monitor these via dashboards to assess the impact of changes made to them via releases or to identify anomalies. SDK logs are exported to the dependency table with the type of SDK. Again, the usage could be to review the number of certain CRUD operations and how long they are taking, or like we said earlier, to identify the end-to-end transaction from an incoming API request and the subsequent SDK calls. And finally, we have exceptions, which exports failures to plugins and SDK operations to the execution table. The exception table is used by App Insights within the failures panel to review each failure and get an aggregated view of failures for review. In our follow-up tech talk, we will dive deeper and take a scenario approach in how you can use the telemetry in these log tables to build out a dashboard based and create certain alerts or critical system operations. Custom dimensions. In addition to the standard schema columns, Dataverse will populate additional telemetry in the schema column called custom dimensions. Please note that these additional schema columns under custom dimensions will differ between tables and certain types. For example, the custom dimensions for the dependency table where the type equals plugin will differ from the custom dimensions where type equals SDK. Custom telemetry. If the standard telemetry doesn't provide some specific metric that you need, you can write a code to supplement what's already being exported. When you have enabled this application insights capability, you can use the iLogger interface in your plugin code to write telemetry data directly to App Insights resource. This telemetry is never sent to Microsoft. When you enable application insights in your organization, any plugins using the iLogger interface provided in the organization service SDK assemblies write telemetry to your application insights resource. Using iLogger provides true telemetry data that is intended to work together with the existing plugin trace logs when written with the iTracing service. Custom telemetry is exported to the trace table in Application Insights. Custo. The Custo query language is a powerful tool to explore your data and discover patterns, identify anomalies and outliers, create statistical modeling, and more. The query uses schema entities that are organized in a hierarchy similar to SQL database tables and columns. A Custo query is a read-only request to process data and return results. In this screenshot, you can see some standard operators and functions typically used with some query examples, again similar to SQL. Please refer to the Custo Queries Learn articles to dive deeper into Custo. Query examples within Application Insights. Sometimes it's easiest to learn by example. The out-of-the-box Application Insight queries will be a good starting point. These queries only use the standard schema, and it's likely you will need to switch some columns around to make the results meaningful, but this is a good starting point in getting familiar with Custo queries. In addition, the Dataverse Application Insights Learn articles have some basic getting started queries. Let's have a high-level view of some of the Application Insights capabilities. The Performance pane allows you to identify the performance of server-side operations, APIs and SDK messages, and also analyze the server operations to determine the root cause of slow performance. You can also identify the slowest client operations from the model-driven app. You can further analyze these details by using them in Custo. You can choose whether server or browser-based views. By identifying those operations with the longest duration, you can diagnose potential problems. The Performance panel shows the count and average duration of each operation for the application. You can use this information to identify those operations that most affect users. The Server view shows the most frequently called APIs and what the latency looks like. Operations with a higher number of calls and high duration are potential items to investigate. In this example, the get accounts has quite a high duration and is called fairly frequently. Selecting this record, you can then drill down further by going into the drill into and further investigate the full end-to-end transaction. If you switch to the browser view, you'll see data about which pages are being viewed most frequently in the environment and the latency for each of them. You'll see metrics including session counts and the dependencies associated with different operations. For example, selecting the accounts operation shows requests made to the account table. Again, you can then drill into the specific sample to see where the time is being sent on that particular operation. The exceptions table in Application Insights powers the failures panel. It shows the count of failed operations and the number of users affected for each operation of the application. You can see error details for the operations and dependencies, for both server and browser failures related to CRUD events and common HTTP methods used in the Dataverse API. You also have the browser view for page loads failures with their dependencies. For example, select an operation that has a high number of failures and users. Selecting this operation shows more information about the dependencies and server response codes. You can also see the failures related to the dependencies, including a summary view of the common response codes mapped to failures in the right-hand panel. You can drill into the details and step into where the bottleneck occurred via Custo queries in logs. In addition, you can review the actions that occur before the error in the user flows, or telemetry for the user session, as well as a timeline for the user and the session. Application Insights has always provided a summary overview pane to allow a quick, at-a-glance assessment of your application's health and performance. Application Insights also allows you to create dashboards, as well as edit the shared Application Insights dashboard. You can pin different charts and views from Application Insights to create custom dashboards that provide you with a complete picture of the health and performance of your implementation. There's a couple of ways to do this. You can create a new Azure Monitor dashboard and then start building metrics from there, or simpler, you can start with either the metrics pane or the logs pane and then pin them to the desired dashboard. In the follow-up tech talk, we will be building out scenario-based metrics and an example dashboard based on some user scenarios that we've had with our custode queries. Alerts help you detect and address issues before users noticing them by proactively notifying you or support teams when Azure Monitor data indicates there might be a problem with your application. You can alert on any metric or log data source in Azure Monitor. Let's create a very simple alert from the exception metric table for demonstration purposes. First, we create a new rule. In the Conditions tab, select the signal. In this case, we are targeting exceptions. You could also target logs, where you can define a custode query with more complex scenarios. We will keep the default threshold, which is any exception in the table. You can also change the evaluation and lookback period on how often the alert should check for exceptions. Next, we will link the alert to an action group, which is where we define the notifications for the alert and how you can also send actions to things such as Event Hub or triggering an Azure function. In this case, we will use the email notification and send the email to myself. Other channels are also supported. You can also define custom properties, which are key value pairs, for any actions that you trigger from the alert. Finally, we will give the alert a name, and then we will save and create. And to finish, here is an example of the test alert where the user can navigate to App Insights to review the exception. Usage and cost estimates. Use the Azure Monitor pricing calculator to estimate your costs. In the search box, enter Azure Monitor and then select the Azure Monitor tile. The pricing calculator helps you estimate your likely costs based on your expected utilization. The bulk of your costs typically come from the data ingestion and retention of your log analytic workspaces and application insight resources. It's difficult to give accurate estimates for data volumes that you can expect because you'll probably vary significantly based on the number of users and usage of your application and the number of integrations and operations in Dataverse. A common strategy is to enable monitoring and identify the costs associated with it within the usage and estimated costs pane in Application Insights. Consider reducing the data retention for the log tables to reduce the costs and also setting a daily volume cap. You can connect log data to Power BI, navigate to the logs pane and create your query. From the export menu, select one of the two options for creating the Power BI dataset. You can either use mQuery or new dataset, the simplest being new dataset based on a direct query. You will then be asked to name the dataset and connect to the desired workspace. You will then be taken to the details page of the new dataset. From there, you can do all the things you can do with regular Power BI datasets, like refresh the data, share the dataset, or create new reports. It's worth noting you can also use Power BI data flows to extract, transform, and load if more data preparation is required.
Thank you, Tom. Let's deep dive into the Azure Application Insights in the Power Platform. In today's session, we will delve into integrating Azure Application Insights with Canvas apps, model-driven apps, and Power Pages websites. In upcoming sessions, we will provide further insights into integrating with Power Automate and additional apps within the platform. Azure Application Insights deeply integrates with model-driven apps, providing performance monitoring, user behavior analysis, and error detection. By embedding the Application Insights SDK, developers can proactively enhance app quality, optimize response times, and improve user engagement through actionable insights. We won't cover the details of the integration of model-driven apps with Azure Application Insights, as you have already been introduced to this process earlier in the presentation with Tom. So with that, similar to model-driven apps, Azure Application Insights also integrates with Power Pages. This integration enables the proactive identification of bottlenecks, optimization of responses time, and improvement of overall user satisfaction. To enable telemetry monitoring for your website, you need to start by activating traffic analytics in the settings area. Then, just like any web-based application, you can employ the Azure Application Insights JavaScript SDK to seamlessly integrate with your Azure Application Insights. The prerequisites for this operation include an Azure subscription with Azure Application Insights resources and contributor role. Additionally, you need the Dataverse environment where you have administrative privileges, as well as an existing Power Pages website. To link your Power Pages website and Azure Application Insights, follow the instructions provided in the video below. This involves injecting the snippet, which you can find in the shared links here. Don't forget to include the instrumentation key to ensure a proper integration. Enhancing context in Azure Application Insights messages is essential for optimizing the service's powerful features. The SDK offers automatic context properties by default and enables developers to further customize them. You can easily manage context for all messages by using the add_telemetry initializer method. Through this approach, you can guarantee that relevant details such as ID, form ID, and system user ID are incorporated into every record stored within the Azure Application Insights table. Furthermore, as mentioned in the previous screen, you have the additional option to enrich the context using liquid template objects. This approach allows for even more dynamic customization, enabling you to include variable information that adapts to different scenarios and user interactions. This capability ensures that the context provided to Azure Application Insights remains highly informative and adaptable, offering a deeper level of insight and analysis. To conclude the tracking script section, it's worth noting that you can also include track event calls in your code to count diverse events. For instance, you might wish to monitor the frequency with which users use a specific feature. Using custom queries in Azure Application Insights enables effective monitoring. By crafting custom queries, you can extract valuable insights from telemetry data. This contributes in the performance analysis, user interactions, and issue identification. This approach facilitates data-driven decision-making for optimizing application performance and user experience. Let's check now the usage. The usage feature in Azure Application Insights provides insights into application usage pattern. By tracking user interactions and engagement, it helps prioritize improvements and customize user experience. Interactive reports facilitate informed decisions, feature optimizations, and ongoing application refinement. Integrating Power Pages with Azure Application Insights provide access to this valuable functionality. The user feature in Azure Application Insights not only provides insights into application usage patterns using the user flow that we have just seen, but also grants access to sessions and end-to-end transactions. An example of such a transaction could involve a user submitting a support case without first checking the knowledge base for existing solutions. Azure Application Insights could effectively track the time taken for each step, highlight instances where users frequently skip the knowledge base search, and offer businesses opportunities to promote checking the knowledge base before submitting a case. This information can be highly valuable for enhancing the support process and elevating the user self-service experience. In the next sessions, we will make sure to provide more examples like this one. Now for the final integration of this session, let's explore connecting your Canvas app to Azure Application Insights. Just like the previous highlights, you can seamlessly link your Canvas app to the Azure Application Insights. The prerequisites remain the same as for the model-driven apps, so primarily an Azure subscription with appropriate privileges and a Canvas app with owner or co-owner roles. Linking the two is a straightforward process. You mainly need to configure the instrumentation ID and you are all set. The main aspect to highlight is that you can directly write custom traces to Application Insights for focused scenario analysis. The trace function facilitates the collection of detailed usage data for control on screens, identification of specific user accessing your application, and the error occurrence. So these traces can certainly be accessed in Azure Application Insights for debugging and analysis purposes, as you have seen for the model-driven apps and the Power Pages. For the monitoring and user analysis, everything we have discussed earlier remains applicable and valuable for analyzing various scenarios that we will try to detail more in the next sessions. And as an example for the user analysis, you can examine common user navigation patterns starting from the home page. For instance, if users frequently move from the home page to a product listing or a specific feature, you can optimize those areas to enhance user engagement. With the conclusion of this overview session, we invite you to join us in the next sessions where we will delve into scenarios addressed by integrating the Power Platform with Azure Application Insights. We will explore